Hello all. So this is the part 3 of the homework, and here I need to vectorize the function which we made over here. This function, the surface function, to find out the points, elliptical points over the helix. So we need to vectorize the surface function, and then we're going to plot the ellipses, and we'll see how it turns out. And the mistake which I did in my last part, see over here, we're getting the error. As I told, there is some mistake which I've done with the parentheses. So over here you can see, instead of the normal brackets, parentheses, I've given square brackets. That's what giving the error over here. So let's remove that. And now you see you are getting 3 points. So at t equal to 0 and theta equal to pi by 4, let me see if I am able to. Yeah, my earphone is connected. Okay, just checked whether my mic is connected. Okay, let's get back to the topic. Here, so at t equal to 0 and theta equal to pi by 4, these are the 3 points we are getting. Okay, so now we need to provide several values of t and thetas. Okay, so to do that, we need to vectorize this function, the surface function. We need to vectorize that. Okay, as given in the question, to vectorize that, will be taking, as you will call in another parameter, we'll call as variable, call as surface vector. Surface vector is equal to jnp dot vectorize. So it's a beautiful thing which is going to vectorize this surface function. Okay, so we are giving, so we'll just put the function name is surface. Then what is the signature? Signature means you're going to provide what kind of things you are providing and what you're going to expecting. Okay, so you're providing two scalar quantities, which is t and theta, and you're getting in vector. So to show that, we put two blank parentheses, which gives us to a vector. Means that there is nothing inside the parenthesis, means it's a scalar, and 3 means a vector with 3 components. Okay, so we're going to continue now. Let's run this. Now, what we're going to do, we're going to give different values of thetas. Okay, so let's get some values of thetas and t's, theta and t. So let's write as t's, jnp dot thin space starts from 0 to 6 pi, which was given in the question. And let's take some values around 100 values of t's and thetas, jnp dot linspace 0 to 2 pi, maybe some values around 27 or 20, let's say 30. Okay, so to make it even better and accessible, you don't have to come again and change. Let's take some parameters as nt. Let's take over here nt as 100, and then theta as 30. So whenever you need to change, you can change directly over there. Nt and n theta. Okay, we got these values. Now if you see, we won't be able to put the values directly. So if you think like just surface, the surface vector, we need different values of theta and t and theta. We need the different points and different values of t and theta. So what are you going to do? We're going to, if you put ts and thetas, you'll see you're going to get error. See, it's showing incompatible shapes. Okay, so to get this, I'll need to introduce a new topic, a new thing called broadcasting. Okay, it's called broadcasting by NumPy. So over here, what you need to do, for every value of theta, see, so there are t values are there and theta values are there. Or you can say like this. Theta values are there. Okay. So we need to create a multiplication table of theta and t. So for each value of t, you need theta values 1, 2, 3, 4, 5. And similarly, second value of t, this is t1, this is t2. T2 will get again theta values of so many theta values. And for t3, you need so many theta values, which means I will tell you. See, this is the helix. Okay. As t increases, we are moving along the axis. If you increase the t from 0 to tn, it is the tn, the t0. Okay. As t increases, we are going to move along the axis, along the helix from the bottom to the top. So for each value of t, we need different values of thetas. Okay. Maybe theta 1 is theta 1, theta 2, theta 3, like this. Okay. And for each part, you'll get going to get three values. Okay, three values means x, y, and z. Okay. So to do that, to achieve this, we're going to use an interesting thing called broadcasting. Okay. Over here, you can see we need to create a multiplication table of t and theta. Okay. So that it should match the shape of t's and shape of t and shape of theta should match. To do that, we're going to add the syntax none. Similarly over here, start with none. Okay, so what it will do, it will going to adjust the t's and thetas to in such a way that they will be able to multiply with each other. So if some rows are missing in thetas, it will going to adjust according to the t's. Okay, and similarly, if any rows or columns are missing in t's, it will going to adjust the thetas according to that. Like if three rows and four columns are there in t's, and four rows and three columns are there in theta. So according to that, we're going to adjust. Like it will put rows and columns of ones uh, according to that requirement. Okay, so we're going to do all these things by itself. So let's run this. Okay, so we got all these values, seven values. Okay, so let's save this into a variable called surface points. These are the surface points. Okay, so it's been saved. If you see the surface point shape, uh, surface point in one surface points. Okay, and it's a typo. Okay, so over here you can see there are 100 T's. This is, you can see this is three components. First one is 100. There are 100 T's. Okay, so at there are 100 T's along the axis. Along these 100 T's, they have calculated 30 thetas. Means there are 30 thetas. So this is the 1T, 2T, 3T, 4T, like this 100 T's. And for each T, there are 30 thetas. Okay, 30 thetas. 30 thetas are there. And for each theta, there are three values of the point three values like x, y, and z. Got it? So along this, we're going to get all these points. Now what we're going to do, we're going to plot the graph. Okay. So let's start. Let's plot the helix first. First we're going to plot the helix, and after that we're going to plot the we already got the points. We just need to plot them along the way of the helix. So let's plot. Let's put fig is equal to mixer plots. Then we need our helix. The way we did before, we just need to do like that only. We're going to put the values of T, R, and Mg. R and G is already defined, and we're going to unpack them into X, comma Y, comma G. Okay, just the way we did it before. We're doing this thing. I showed how to do it. So just do like this, and to get the values of T's, we'll take the values of T's like J dot lim space from 0 to 6 pi. Let's take around 1000 points. Let's take around, yeah, let's take around 1000 points. 10 times the number of entities. Something like that I can take. Okay, now, so we got this. Let's plot our helix scatter 3D, x equal to x, y equal to y, g equal to g, and mode is equal to lines, and we'll see our helix. Okay, this is our helix. Uh, Now to plot our what do you call our to plot our ellipses along the line. So if you start with this point, see look at this point, we're going to start from here and we'll go along the way of the helix from the top to the bottom, or you can start from bottom because we've given this thing. So we'll start from the bottom and go to the top because Python helix can start from zero. So we'll start from zero to the bottom to the top. Okay. So to do that, what we're going to do, we're going to use for loops because for each t, we need to plot the thetas. Okay, so we'll make every t constant for t equal to 1, we're going to plot all the thetas, and for each theta, we're going to plot x, y, z. Similarly, for t equal to 2, we're going to plot all the 30 thetas or whatever number of thetas are there, and for each theta, we're going to plot x, y, and z. Okay, similarly, we're going to do that. After that, we're going to keep t constant and we'll plot different values for theta. So we're going to do that. So let's start with this. So for I in range of nt, means nt values are there. We're going to unpack x, y, z is equal to surface points. It starts with I, means we're going to take all the t's, okay, 0 to 100, and for each t, we're going to plot all the thetas. All the theta means colon, comma, all the x, y, z, so colon. We're going to plot like this. Let's put this. I'm going to copy and paste. Let's give some different color to this just to recognize, like line color is equal to, let's give red. Okay, so our ellipses will be red. Okay, one more thing I completely forgot. Over here, they are saying too many values to unpack. See, they are in in line vectors, like the x, y, z values are in the lines. Okay, so we need to convert into transpose it into the columns. So we need to transpose it dot t. Now it's showing. Let's plot the other value, the theta value as well. Right, so let's copy this, paste this. Let's take it as j in thetas and theta, right? Yeah, and theta. Now we need all the values of t, but we're going to change for each value of t, we're going to change the value of theta. So we're going to put as j over here and we'll change this color to blue. Why not getting that? Okay, let's uh, put this fit dot update layout. Width is equal to, let's take 800. Height is equal to, let's take 1000. And template is Lotley dark, and that's it. Okay, so we got our values. We need to remove these legends. So we'll put like so legend legends is equal to false. So it's not going to show any legend now. Over here, as you can see, we got our helix. Okay, but the pitch is a bit higher, like it's calling very sharply. So we might need to reduce this thing. Let's make it as pi only or 4 pi and shift enter. Okay, as you can see, the pitch has reduced significantly, and you can see, uh, okay, let's change the color of our helix first. Let's make it as white or something so we'll be able to see clearly. Okay, so over here, as you can see, this is our helix. Helix is going in this way, and we plotted several ellipses along the line of the helix. So this is the first helix at t equal to 0 and t equal to, some t, there is some other value, we're going to plot another thing. And you can see over here, let me show you properly. I'm not able to zoom it, not getting the proper viewing angle. Okay, here you can see, if you see, there are several values. See, this is the theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7, theta 8, like this. 30 values of thetas are there. Over here, we have taken it equal 30. So 30 values of theta are there. And for each value of theta, there are three values of x, y, and z coordinates. And this continues along the axis. Okay. Okay, it continues along the axis. And we get this elliptical cross section. And so that was it for the part 3 of the homework. And in the next part, we're going to calculate the surface area of this helix, and after that, we're going to check that whether it's right or not using the traditional method, like which is equal to calculate the arc length of the helix multiplied by the surface area of each ellipse. So just multiply that, like do it for the cylinder, which is the 2 pi r is the same formula I'm going to use it, and we're going to check whether we're getting the right answer or not. Okay, so catch you guys in the next part.